Once again, hello everyone, I am Rosito Orquesta and welcome to Pantas Malaya. So in a continuation to our previous topic last week about the platform technologies, we stopped at the major components of the operating system. Now we are going to talk about the six major components of the operating systems, which are the file management, the process management, the I/O device management, the network management, secondary storage management, and the security management. So first, let's jump to file management. So file management, as per definition, a file is a set of related information which is should defined by its creator. It commonly represents programs. It has both the source and object forms and data. While data files can be numeric, alphabetic, or alphanumeric. These are the functions of the file management in operating systems. Uh, say the file and directory creation and deletion, for manipulating files and directories, mapping files onto secondary storage, backup files on stable storage media. When we say file and directory creation, deletion, it means that it is the responsible of how your files will be created according to the data types, and how it will be saved in your device. And as for the deletion part, it will also manage on which of the files will be removed from your storage media. Manipulating files and directories, the file management will arrange your files according to its types, use, and also a time. So it will also map the files into the secondary storage. How will it be saved in your, say for example, in your pen drive, in your hard disk drive, in your solid state drive or the SSD. So it will also let you backup files on stable storage media, like copying and pasting it into another storage. So copy paste. So that's the functions of the file management in our operating system. Okay, so one of the major purpose of the file management is if we visualize our device storage media, so somehow it will look like this. It is composed of rows and columns. So let's imagine it is composed of rows and columns, and each of the intersection of the rows and columns has formed a cell. That cell is what we call a sector in our storage. Those are sectors. Instead of cells, we call that sectors, and each of the sectors has different address. Like for example, in this we have the first cell or the first sector could be called B2, and then the C2, and then we have the B3. So in this manner, as per this function, mapping files into the secondary storage, so the purpose of that is when you say you are having a file, a word file. This is a word file. This word file will be mapped into your device, into your storage device. See, it will occupy at least 3 blocks or 3 cells or 3 sectors in your storage, and this sector has different names, right? We have the B2, the C2, and then the D2. So every user save this Word file, it will be like this. And if the user open this file, it will manage to open the actual Word file by determining the name of these sectors. It will look for B2, C2, and D2 so that it can provide the whole Word file to the user. Also, if there are times that the systems are cluttered, or the files are being cluttered in the system, so it will arrange this, remove these blanks and or bad sectors. See, we have bad sectors. It will arrange this and kept an eye to this bad sector. So from here it will be moved here, and these three sectors will be moved here, and this will return to blank. So another purpose of file management. Then for the process management, by definition, the process management component is a procedure for managing the many processes that are running simultaneously on an operating system. So every software application program has one or more processes associated with them when they are running. Say for example, in a browser, if we right click this browser and open the task manager, so as you can see, there are different processes, sub-processes that is running inside this task manager of the browser. While as you can see, I only have one tab, but the system task manager has shown us different processes. Some of those are the system processes and the plugins. So like these plugins could could have an actual sub-process in the system. So all these processes should be managed by process management, which keeps processes for running efficiently. It also uses memory allocated to them and shutting them down when needed. The execution of a process must be sequential, so at least one instruction should be executed on behalf of the process. These are the functions of the process management: the process creation and deletion, suspension and resumption, the synchronization process, communication process. When you say process creation and deletion, it means that the OS will be responsible, or the process management of the operating system is responsible for creating a new process for the central processing unit. It will tell the central processing unit to process this one and to stop or delete this process. So creation and deletion. It will also suspend and resumption. A best example of this suspension and resumption in a process is that when you have opened different tabs in your browser, especially in Chrome, mostly in Chrome, since you are a fan of Chrome. When you open different tabs, especially when you are researching something, then you forgot to, or you want to save a current tab for a later part of your research. So tendency it will be suspended by the process management. It will as you can observe, it will grayed out that specific tab for like if you are not interacting with that tab for at least an hour. I guess I can tell you the specific length of time before it gets suspended or it get grayed out. But yeah, you will experience that one. And when you click back on the tab, it will the resumption happen. It will reload all the resources, the previous resources on the previous display. So that means that there is a suspension or resumption happening in the process of the tab. While in synchronization process, it is so for example, you are opening a single program, a single application and that application has different processes like this browser, and those sub processes should be synchronized in execution time before it can produce an output. See, this process one could not produce an output without this process, so these two processes will be synchronized, or shall we say, if this process first, then this will proceed so to produce one single output. So that is a synchronization of the process, or a time. Say for example, this process first, then this second process, then another third process, and then create a single output, then produce the output. So it will communicate process also. So it will manage to create a communication between processes. So that is the functions of the process management inside our operating system. Now, if we talk about the I/O device management, this is one of the important use of an operating system that helps you to hide variations of specific hardware device from the user. So first, it offers a buffer caching system. It provides general device driver code. It provides drivers for particular hardware devices, and I/O helps you to know the individualities of specific device. For this example, the buffer caching system is that one best example is a common and is viewable, or you can always see this as an example. If you are going to print different files, different text file in your printer, and in the lower right corner of your screen monitor, you can see an icon for that printer, and when you open that icon, when you double click that icon, you will see a queue of jobs. So that is polling, we call that polling. It is kept in the buffer caching system of that I/O device. So the caching system is it will arrange what are the things to be outputted. If it is an output, what are the commands that are being accepted from the input. If it is an input device, it's like a storage, a cache for the commands in each of the I/O device that is connected in your computing machine. It also provides general device driver code, since the device is connected into your system, to your computer or operating system, will not run, it will not function if there is no specific driver code that will let the device, as well as the device be connected to the operating system, and it will also let the central processing unit be communicate to that I/O device. So for example, you have two different printers. You have the Epson and the Epson and the brother. When you connect it into your machine, by default, if you are using in Windows 10 operating system, it will create you a default driver code. But to maximize the performance of your device, you have to install specific driver from its website, or a pack CD from your from where you purchase that peripheral or the printer. So your operating system, especially the I/O management, will cater those drivers. And as for the operating system, we have different types of operating system. So we have the batch operating system, the multiprogramming operating system. We also have the multiprocessing system and the real-time operating system. If we talk about the batch operating system, in the year of 1970s and the previous decades, the batch processing was very popular. The jobs were executed in batches. People were used to have a single computer, which was called mainframe. It is a big computer system. In batch operating system, access is given to more than one person. So if you happen to have a subject about um, history of computer, you will see a mainframe. That is a robust, a big computer. They submit their respective jobs to the system for the execution. The system put all the jobs in a queue on the basis of first come first serve, and then executes the jobs one by one. The users collect their respective output when all the jobs get executed. So this is a we have here a diagram of a batch processing. Uh, in the operating system, the jobs are queued, the job 1, 2, 3, and up to the last job, and then it will be processed one by one, and then all the result will be produced by batch. So job comes in batch, jobs be processed in a first come first serve basis, job outputs will be released in a batch. So another diagram for the batch processing. Okay, so you can see in the diagram we have job 1, job 2 up to the last job, or the job n comes to the operating system, and then it will be performed according to the first come first serve basis, and then that will be uh, it will release the output in batches also. But there are disadvantages in using a batch operating system. We have two, at least two. The first one is starvation. When we say starvation, it is when the first job is taking a lot of time to perform or to finish the job. It will we will have the or there will be going a tendency that the other jobs, the second to the last job, will not get executed, or they will have to wait for a higher wait time. Hence, the other process is being starved. So that's what is the starvation means. So the first job performs a specific length of time, longer time than the other jobs. So the other jobs has to wait. They will not be executed, or they will have to wait for a longer time before being executed. And it is not interactive. The second disadvantage of batch operating system is that it's not interactive. If you say it's not interactive, you cannot manipulate the process, you cannot supply additional input, additional resources while the job is being processed. So before the job is will be processed, you have to supply all the information needed and resources needed for that job on in the beginning, because when it is being processed, you cannot interrupt the process, you cannot interact with the process, you cannot interfere with the process, you cannot supply additional input, you cannot supply additional resources. So what you are going to do is just wait for the outcome. So that is the what's disadvantages about having batch operating system. If we go back to the starvation, unlike of today's computer system that it can multitask. So starvation is having a computer that could not cater a multitask. Then we have the multiprogramming operating system. So multiprogramming is an extension to the batch processing where the CPU is kept always busy, and each process needs two types of system time, the CPU time and the IO time. That's mean we are having a clocking here. So the specific length of time that the central processing unit is to perform while it is the input is accepting resources or commands. In multi-programming environment, for the time a process does its I/O, the CPU can start the execution of other processes. Therefore, multiprogramming improves the efficiency of the system as per time is concerned. So what happened here is that if we make a comparison between the batch processing and multiprogramming, is that although the multiprogramming is we could say it is um, belongs to the batch processing, but uh, there's some changes, small changes in the multiprogramming. Say if this batch processing is about taking all the jobs in, then processing that job one by one, then release the result by batch. In multiprogramming is that after accepting the first job, it will process that job, and while it processes that job, the first job, the system will accept the second job, and then this first job will be outputted. So the central processing unit is the process is now empty. So the second job will be moved to the process while it accept another job from the input. So there is a chain, like a chain. So the CPU or the process will not get starved because it continues to process while it is accepting input or producing an output. So that's the difference between the multi-programming operating system. Although with against the batch processing, although it still follow the first come first serve method of processing the requests or the jobs. But as per time is concerned, with the implementation of multi-programming operating system, it is more faster and efficient compared to the batch operating system. Then after that, so here is an example of a diagram of the multi-programming operating system. So it could process word, it could accept word processor, email, web browser, antivirus to operating system. While in the previous operating system, it will only accept this word processor, process, email, then web browser, then antivirus. But here we could almost simultaneous, but not really simultaneous because it follows the first come first serve uh, programming. And then comes the multiprocessing operating system. So it has implemented the parallel computing. There are more than one processor present in the system which can execute more than one process at a time or the same time. So this will increase the throughput of the system. So if you happen to remember, if you are that old enough, you maybe remember those previous types of processor. We have the dual core, core to duo, quad core to quad. Yeah, those operating systems, and then we have the Core I series. But before that, we have Pentium. We have Pentium, then the Core series up to the Core I series, and then on the other company, we have those Ryzen series. So this has multi-core CPUs. It has multi-core, so it could cater multiprocessing, it could cater multitasking. So in multiprocessing operating system, it means that different jobs could be performed simultaneously or at the same time, and it could produce a result at the same time. Like this in the diagram, we have the job 1, 2, and job 3 perform the same time and could produce an output and could output at the same time, uh, or differ in time depending on the the length of the process of the job. But the good thing is that it could be all the jobs could be processed at the same time. So it will not wait for the other job to get finished before the second job will be performed. So multiprocessing. with multi-core, multitasking. So that's the main multi-processing operating system. And then we have the real-time operating system. If it's a real-time operating system, it carries a certain deadline within which the job is supposed to be completed. Otherwise, the huge loss will be there, or even if the result is produced, then it will be completely useless. So the application of a real-time system exists in the case of military applications, like for example, if you want to drop a missile, then the missile is supposed to be dropped with a certain precision. But this real-time operating system, the output of a real-time operating system could be hindered by outside or external interference, as you see. So, say for example, if this in this example of military application that you are to drop a missile, that missile could not precisely drop to a specific location because of, say for example, if there is a change in weather, so it could hinder the performance of that operating system. So it's beyond the operating system, so it's not 100% accurate because the output of that example could be hindered by an external interference, or other variables could miss the output. So those are the types of operating system: the real-time operating system, the multiprocessing operating system, the multiprogramming operating system, and the batch operating system. So that's all for today. Thank you everyone. If you have questions and clarifications, please comment down below. Thank you.